Welcome to Tech with Kaushik. This is part 1 of our complete practice question series for the DVA-C02 AWS Certified Developer Associate exam. Choose your answer before the timer ends. Then review the correct answer, explanation, and exam tip. Let us begin part 1. Question number 1. A healthcare analytics provider retains immutable clinical records in Amazon S3. Authorized staff must retrieve the original objects, but external researchers must receive the same objects with all patient identifiers removed. A Lambda function named redact patient data already performs the redaction. The provider must keep only one stored copy of each record. Which implementation meets these requirements? Option A. Configure an S3 put event notification to invoke redact patient data and use put requests to retrieve redacted data. Option B. Create an S3 object Lambda access point that invokes redact patient data and use that access point for redacted reads. Option C. Create a standard S3 access point and pass redact patient data to the getObjectLegalHold API operation. Option D. Configure an S3 get event notification to invoke redact patient data and use get requests to retrieve redacted data. The correct answer is B. Create an S3 object Lambda access point that invokes redact patient data and use that access point for redacted reads. Here's why. S3 object Lambda can transform getObject responses with Lambda while the original object remains unchanged, so one stored copy can serve authorized and redacted views. Why are the other options not correct? A. Put notifications do not transform reads. C. GetObjectLegalHold manages legal-hold state and cannot invoke a transform. D. S3 does not provide get event notifications that rewrite object responses. Exam tip. Use S3 object Lambda when different consumers need transformed views of the same stored object. Question number 2. A team publishes updates to an AWS Lambda function several times each week. The team needs a quick way to redirect production traffic to a previously published function revision with minimal administration. Which approach should the team use? Option A. Store every deployment package in Amazon S3 and manually redeploy an older package. Option B. Use AWS code pipeline to recreate the function whenever a rollback is required. Option C. Publish Lambda versions and move a function alias to the required version. Option D. Use AWS OpsWorks to perform blue/green deployments for the function. The correct answer is C. Publish Lambda versions and move a function alias to the required version. Here's why. Published versions are immutable, and an alias can be repointed quickly to an older version without rebuilding or redeploying code. Why are the other options not correct? A. Manual package redeployment adds work. B. Code pipeline is unnecessary for simple version switching. D. OpsWorks is not the native rollback mechanism for Lambda. Exam tip. Use Lambda versions for immutable releases and aliases for stable routing and rapid rollback. Question number 3. An application is deployed to Amazon EC2 instances by using an AWS code deploy in-place deployment. Which sequence correctly lists the relevant lifecycle hooks? Option A. Before install leads to application stop, leads to application start, leads to after install. Option B. Application stop leads to before install, leads to validate service, leads to application start. Option C. Application stop leads to before install, leads to after install, leads to application start. Option D. Before install leads to application stop, leads to validate service, leads to application start. The correct answer is C. Application stop leads to before install, leads to after install, leads to application start. Here's why. For an EC2/on-premises in-place deployment, code deploy runs application stop before installation hooks, then starts the application after install. Why are the other options not correct? A, B, and D place lifecycle hooks in the wrong order or substitute validate service before application start. Exam tip. Know the code deploy in-place sequence. Stop, prepare/install, start, then validate. Question number 4. A media platform runs a moderation service on EC2 instances. The service calls an external messaging API with an access token whenever prohibited content is detected. The token must be encrypted in storage and transit and must be retrievable by workloads and other AWS accounts with the least management overhead. Which solution should the developer implement? Option A. Encrypt the token with an AWS managed KMS key, store it in S3, and grant cross-account access through a bucket policy. Option B. Store the token in Secrets Manager with a customer-managed KMS key, add a resource policy for approved accounts, and grant the EC2 roles permission to retrieve the secret. Option C. Store the token in DynamoDB after encrypting it with a customer-managed KMS key, then decrypt it on each EC2 instance. Option D. Store the token as a parameter store secure string encrypted with an AWS managed KMS key and attach a cross-account resource policy to the parameter. The correct answer is B. Store the token in Secrets Manager with a customer-managed KMS key, add a resource policy for approved accounts, and grant the EC2 roles permission to retrieve the secret. Here's why. Secrets Manager provides managed secret storage and TLS access. A customer-managed KMS key and secret resource policy support controlled cross-account retrieval. Why are the other options not correct? A. An AWS managed KMS key is unsuitable for this cross-account pattern. C and D require custom storage and decryption workflows with more management. Exam tip. For cross-account secrets, use a resource policy plus a customer-managed KMS key and least privilege IAM permissions. Question number 5. A software company operates EC2 instances in several AWS accounts. All instance state change events must be centralized on one event bridge event bus and then delivered to an SQSQ in the audit account. Which configuration meets the requirement? Option A. Grant the central event bus permission to receive events. In every source account, create a rule that forwards EC2 state change events to the central bus. On the central bus, create a rule whose target is the SQSQ. Option B. Add the central SQSQ directly as the target of a rule in every source account after granting queue access. Option C. Poll every account with a scheduled Lambda function and send detected changes to the central queue. Option D. Configure EC2 in each account to publish state changes directly to the central event bus without source account rules. The correct answer is A. Grant the central event bus permission to receive events. In every source account, create a rule that forwards EC2 state change events to the central bus. On the central bus, create a rule whose target is the SQSQ. Here's why. Cross-account event bridge routing requires permission on the destination bus and forwarding rules in source accounts. A central rule can then send matching events to SQS. Why are the other options not correct? B. Bypasses the requested central bus. C. Uses polling and can miss timely changes. D. Incorrectly assumes EC2 publishes directly to another account's bus. Exam tip. Cross-account event bridge uses source rules, destination bus permissions, and destination rules. Question number 6. An S3 object-created notification successfully invokes a Python Lambda function. The function reads the new object, but receives an authorization error when it attempts to write an item to DynamoDB. What is the most likely cause? Option A. The DynamoDB table is in a different availability zone from the function. Option B. The table does not have a global secondary index. Option C. The function's execution role lacks the required DynamoDB write permissions. Option D. The function exceeded its concurrency quota. The correct answer is C. The function's execution role lacks the required DynamoDB write permissions. Here's why. The successful invocation proves the trigger works. Downstream DynamoDB calls are authorized by the Lambda execution role, which needs actions such as DynamoDB, put item. Why are the other options not correct? A. DynamoDB is regional, not availability zone bound. B. A GSI is not required for writes. D. Concurrency exhaustion would affect invocation, not only the DynamoDB call. Exam tip. Lambda execution roles control what the function can call. Resource policies control who can invoke it. Question number 7. A CloudFormation template accepts an EC2 instance type as an input. An organization permits only a defined set of instance types, and deployments must reject any other value. How should the parameter be defined? Option A. Define one parameter for every permitted instance type. Option B. Add an allowed values constraint containing the approved instance types. Option C. Create a resource for every permitted instance type. Option D. Maintain a separate template for each permitted instance type. The correct answer is B. Add an allowed values constraint containing the approved instance types. Here's why. Allowed values restricts a parameter to an enumerated set and causes invalid stack inputs to fail validation. Why are the other options not correct? A, C, and D duplicate parameters, resources, or templates instead of constraining one reusable parameter. Exam tip. Use CloudFormation parameter constraints, such as allowed values, to enforce approved inputs. Question number 8. An application calls DynamoDB batch get item and sometimes receives keys and unprocessed keys during traffic peaks. Which two actions improve resiliency? Option A. Increase the table's provisioned write capacity. Option B. Retry the unprocessed keys immediately without delay. Option C. Retry the unprocessed keys with exponential backoff and jitter. Option D. Increase the provisioned read capacity for the affected tables. E. Replace the low-level requests with an AWS SDK without changing retry or capacity behavior. The correct answer is C. Retry the unprocessed keys with exponential backoff and jitter. D. Increase the provisioned read capacity for the affected tables. Here's why. Unprocessed keys indicates that some reads were not completed, commonly because of throttling. Retrying with backoff and adding read capacity addresses transient and sustained pressure. Why are the other options not correct? A. Increases write capacity, which does not help batch get item reads. B. Can worsen throttling. E alone does not guarantee correct handling of unprocessed keys. Exam tip. For DynamoDB batch reads, retry only unprocessed keys with backoff. Add read capacity when throttling persists. Question number 9. A company has enabled X-ray tracing on an API gateway test stage. Requests then reach an application running on on-premises Linux hosts. The developer wants those hosts to send trace data to X-ray with the least setup. What should the developer install and run? Option A. An X-ray daemon that receives trace segments from instrumented application code and forwards them to X-ray. Option B. A Lambda function that calls put telemetry records for captured requests. Option C. Only the X-ray SDK, which independently forwards all trace data without a daemon or collector. Option D. A Lambda function that polls the hosts and calls put trace segments. The correct answer is A. An X-ray daemon that receives trace segments from instrumented application code and forwards them to X-ray. Here's why. The X-ray daemon is the local process that listens for trace data from the SDK and relays segments to the X-ray service. Why are the other options not correct? B and D add unnecessary Lambda polling. C is incomplete because the SDK instruments code but normally sends segments to a daemon or compatible collector. Exam tip. X-ray SDK's instrument applications. The daemon or collector forwards trace data to X-ray. Question number 10. A university is replacing an internal faculty directory with AWS services. The application must retrieve each person's searchable profile data and high-resolution portrait through AWS APIs. Which storage design is most appropriate? Option A. Store profile attributes in DynamoDB and store each portrait in S3. Save the S3 object key with the profile. Option B. Store profile data in RDS and portraits in EFS. Option C. Base 64. Encode profiles and portraits and store all content in DynamoDB. Option D. Use a Cognito user pool as the directory and image repository. The correct answer is A. Store profile attributes in DynamoDB and store each portrait in S3. Save the S3 object key with the profile. Here's why. DynamoDB supports low-latency profile lookup, while S3 is designed for large binary objects. Storing the S3 key links metadata to each portrait. Why are the other options not correct? B adds relational and file system administration. C is inefficient and constrained by DynamoDB item size. D. Cognito is an identity service, not a general image directory. Exam tip. Store searchable metadata in DynamoDB and large objects in S3, linked by object keys. Question number 11. A mobile application uses Cognito user pools and identity pools. Signed-in users upload and download files between 3 kilobytes and 300 megabytes from S3. Each user must be authorized to access only objects in that user's own prefix. Which solution provides the strongest direct enforcement? Option A. Use S3 event notifications to validate requests after they occur. Option B. Filter file listings in the client by comparing user IDs stored in DynamoDB. Option C. Route every transfer through API Gateway and Lambda and validate ownership in function code. Option D. Use an IAM policy with Cognito identity variables to restrict each identity to its own S3 prefix. The correct answer is D. Use an IAM policy with Cognito identity variables to restrict each identity to its own S3 prefix. Here's why. Identity pool credentials can receive scoped IAM permissions that enforce each user's S3 prefix at the service authorization layer. Why are the other options not correct? A validates too late. B is only UI filtering and does not enforce access. C adds an application layer and transfer limits instead of direct S3 authorization. Exam tip. Use Cognito identity credentials plus IAM policy variables for per user S3 prefixes. Question number 12. A data processing application applies several business rules in a required sequence. Failed steps must support controlled retries and reprocessing. The workflow must scale without the team maintaining orchestration servers. Which service should coordinate the processing? Option A. AWS Lambda. Option B. AWS Glue. Option C. AWS Step Functions. Option D. AWS Batch. The correct answer is C. AWS Step Functions. Here's why. Step Functions provides managed workflow orchestration, ordered state transitions, retries, catches, and reprocessing without maintaining orchestration servers. Why are the other options not correct? A is compute, B is primarily data integration /ETL, and D schedules batch compute, but does not directly model the required business workflow. Exam tip. Use step functions for managed sequencing, retries, branching, and error handling across application steps. Question number 13. A production REST API and API gateway is used by customers through a Cognito authenticated web application. A backward incompatible API revision must be available to internal developers for beta testing without changing the production client experience. Which solution has the least operational overhead? Option A. Add a query parameter to application code that selects the implementation version. Option B. Create a development stage for the API and give testers the stage-specific endpoint. Option C. Create an entirely separate API gateway REST API. Option D. Add the new resources directly to the production stage. The correct answer is B. Create a development stage for the API and give testers the stage-specific endpoint. Here's why. API gateway stages isolate deployments and expose separate URLs, allowing beta testing without changing the production stage. Why are the other options not correct? A adds custom version routing code. C duplicates the API and increases administration. D risks exposing incompatible changes to production users. Exam tip. Use API gateway stages to separate development, test, beta, and production deployments. Question number 14. A Windows application being moved to EC2 currently reads shared XML configuration files from a network folder. The replacement repository must be highly available and cost-effective. The application can be updated to use AWS APIs. Which design should the developer choose? Option A. Store the XML files in S3 and update the application to read and write them with the AWS SDK. Option B. Attach an EBS volume to one EC2 instance and share the folder from that host. Option C. Store the files on an instant store volume attached to a small EC2 instance. Option D. Mount an S3 bucket as a local disk and continue using file system operations. The correct answer is A. Store the XML files in S3 and update the application to read and write them with the AWS SDK. Here's why. S3 provides durable, highly available object storage without a single EC2 file server dependency and is cost-effective for configuration objects. Why are the other options not correct? B and C create single host failure points. Instance store is ephemeral. D assumes file system semantics instead of using supported S3 APIs. Exam tip. For shared durable configuration objects, prefer S3 APIs over self-managed single-instance file shares. Question number 15. An application is expanding into another AWS region. Some source AMIs are unencrypted, but organizational policy requires every AMI used in every region to be encrypted. Which approach satisfies the policy? Option A. Copy the unencrypted AMIs first, then enable EBS encryption by default in the destination region. Option B. Use ACM to encrypt the existing AMIs before copying them. Option C. Create encrypted AMIs from the workloads. Copy those encrypted AMIs to the destination region and retire the unencrypted images. Option D. Enable KMS encryption directly on each existing unencrypted AMI and then copy it. The correct answer is C. Create encrypted AMIs from the workloads. Copy those encrypted AMIs to the destination region and retire the unencrypted images. Here's why. Encrypted AMIs can be copied across regions while retaining encryption. Creating encrypted replacements ensures only compliant images are used. Why are the other options not correct? A leaves copied images unencrypted. Default encryption does not retroactively encrypt them. BACM does not encrypt AMIs. D. Existing AMIs cannot be toggled to encrypted in place. Exam tip. AMI encryption is applied when creating or copying images. It is not enabled in place on an existing AMI. Question number 16. Several browser-based applications are hosted from separate S3 origins and CloudFront distributions. They load shared JavaScript and font assets from a central S3 origin. Browsers reject those cross-origin asset requests. What should be configured on the central bucket? Option A. A content MD5 header for every asset request. Option B. A CORS configuration that permits the required origins and methods. Option C. Separate S3 access points for each application bucket. Option D. A bucket policy only, without CORS response headers. The correct answer is B. A CORS configuration that permits the required origins and methods. Here's why. Browsers enforce the same origin policy. S3 must return appropriate CORS headers for allowed cross-origin JavaScript and font requests. Why are the other options not correct? A verifies integrity only. C changes access endpoints, but not browser CORS behavior. D. Authorization alone does not supply CORS response headers. Exam tip. Bucket policies control authorization. CORS controls whether browsers permit cross-origin responses. Question number 17. An application is processing clickstream data using Amazon Kinesis. The clickstream data feed into Kinesis experiences periodic spikes. The put records API call occasionally fails, and the logs show that the failed call returns the response shown below. Failed record count, 1. Records. Sequence number, 212693199899006379465403778482371. S. Shard ID, 0000000000001. Error code, provision exceed det exception. Error message, rate exceeded for shard ID, 00000000001 in. Stream example stream name under account 123456769. Sequence number, 21269319989963794061778477846829885. S. Shard ID, 0000000000002. Which techniques will help mitigate this exception? Choose 2. Option A. Implement retries with exponential backoff. Option B. Use a put record API instead of put records. Option C. Reduce the frequency and/or size of the requests. Option D. Use Amazon SNS instead of Kinesis. Reduce the number of KCL consumers. The correct answer is A. Implement retries with exponential backoff. C. Reduce the frequency and/or size of the requests. Here's why. The provision throughput exceeded exception indicates that write traffic to a shard exceeds its available throughput. The producer should inspect the put records response, retry only the failed records with exponential backoff and jitter, and reduce the request rate or request size. Why are the other options not correct? B. Put record sends one record per request. It does not increase shard capacity and can increase the number of API requests. D. Amazon SNS does not replace Kinesis for ordered, shard-based streaming and replay. E. KCL consumers affect read throughput. The exception shown is caused by producer write throughput on a shard. Exam tip. Put records can partially succeed. Check failed record count and each record's error code. Then retry only failed records with exponential backoff. Question number 18. An application authenticates users with a Cognito user pool and MFA. After every successful authentication, the company must send an email notification with minimal operational complexity. Which implementation should be used? Option A. Invoke an SES sending Lambda function from a Cognito post-authentication trigger. Option B. Stream Cognito logs through Kinesis Data Firehose and inspect them with Lambda. Option C. Call an API gateway endpoint from the client after login. The endpoint invokes an SES sending Lambda function. Option D. Subscribe a Lambda function to CloudWatch logs and infer successful logins from log entries. The correct answer is A. Invoke an SES sending Lambda function from a Cognito post-authentication trigger. Here's why. The post-authentication trigger runs after successful authentication and directly invokes Lambda, making it the simplest event-driven place to send the email. Why are the other options not correct? B and D add log pipelines and indirect detection. C depends on untrusted client behavior and adds API gateway. Exam tip. Use Cognito post-authentication triggers for actions that must run after each successful sign-in. Question number 19. An application calls a partner's HTTP API by using an API key. The key must be managed securely from code and retrieved without embedding it in the source repository. Which solution is most secure? Option A. Store the key in DynamoDB and retrieve it with the SDK. Option B. Store the key in a private S3 object and retrieve it with the SDK. Option C. Store the key in Secrets Manager and retrieve it at runtime with the AWS SDK. Option D. Place the key in a source code variable in a private Git repository. The correct answer is C. Store the key in Secrets Manager and retrieve it at runtime with the AWS SDK. Here's why. Secrets Manager is purpose-built for protected secret storage, controlled retrieval, encryption, and optional rotation without committing credentials to source. Why are the other options not correct? A and B use general-purpose stores and require more custom security handling. D exposes the key to source control and deployments. Exam tip. Keep API keys out of code. Retrieve them from Secrets Manager through an authorized runtime role. Question number 20. An ECS application requires environment-specific API endpoints, authentication settings, and credentials for development, test, and production. The values must remain available to future task revisions while requiring the fewest application changes. Which approach should the developer use? Option A. Store configuration values under environment-specific parameter store paths and store credentials in Secrets Manager. Option B. Save encrypted configuration files inside each application image. Option C. Represent the API URL and credentials as KMS keys. Option D. Hardcode unique variable names in every ECS task definition and make the application retrieve values from each environment. The correct answer is A. Store configuration values under environment-specific parameter store paths and store credentials in Secrets Manager. Here's why. Parameter store organizes environment-specific configuration, while Secrets Manager protects credentials. Both persist independently of ECS task revisions. Why are the other options not correct? B couples configuration to images. C KMS manages keys, not arbitrary configuration storage. D creates deployment-specific coupling and more application logic. Exam tip. Separate configuration from deployments. Parameter store for settings and secrets manager for credentials. Question number 21. A photo sharing service must support tens of thousands of registered users. API Gateway and Lambda Process API. Requests. DynamoDB stores photo metadata, and image sizes range from 300 kilobytes to 5 megabytes. Which design has the least operational overhead? Option A. Create an IAM user for every customer. Use IAM authentication. Store images in S3 and save their keys in DynamoDB. Option B. Manage users with Cognito user pools and an API Gateway Cognito authorizer. Store images in S3 and image keys in DynamoDB. Option C. Manage users in a custom DynamoDB table with a Lambda authorizer. Store images in S3 and keys in DynamoDB. Option D. Use Cognito authentication but store both image binaries and metadata directly in DynamoDB. The correct answer is B. Manage users with Cognito user pools and an API Gateway Cognito authorizer. Store images in S3 and image keys in DynamoDB. Here's why. Cognito provides managed sign-up and authentication. S3 stores image objects efficiently, and DynamoDB stores searchable metadata and S3 keys. Why are the other options not correct? A creates unscalable IAM users. C requires a custom identity system and authorizer. D stores multi-megabyte binaries in DynamoDB and can exceed item size limits. Exam tip. Use Cognito for app users, S3 for binary objects, and DynamoDB for metadata. Question number 22. A logistics platform processes requests from many business partners through API Gateway and a shared Lambda function. After processing, each partner must receive only notifications for that partner's requests. Adding a new partner should require minimal code changes. Which design is most scalable? Option A. Publish all notifications to one SNS topic and subscribe every partner without filters. Option B. Deploy a dedicated Lambda function for every partner and call each endpoint directly. Option C. Create one SNS topic, add partner attributes to messages, and apply subscription filter policies. Option D. Create and manage a separate SNS topic for every partner. The correct answer is C. Create one SNS topic, add partner attributes to messages, and apply subscription filter policies. Here's why. SNS subscription filters route each message only to matching partner subscriptions, while one topic and publishing path support future partners. Why are the other options not correct? A sends every message to every partner. B and D create per partner compute or topics and increase code and operational overhead. Exam tip. Use SNS message attributes and subscription filters for scalable selective fanout. Question number 23. A Lambda function performs CPU-intensive calculations and its response time is too high. Which configuration change is most likely to reduce execution duration? Option A. Increase the function timeout. Option B. Increase reserved concurrency. Option C. Increase the function's memory allocation. Option D. Configure a CPU core count independently of memory. The correct answer is C. Increase the function's memory allocation. Here's why. Lambda allocates CPU proportionally with memory. A higher memory setting can provide more CPU and reduce duration for CPU-bound workloads. Why are the other options not correct? A only permits longer execution. B changes concurrency, not single invocation speed. D CPU is not configured independently in Lambda. Exam tip. For CPU-bound Lambda functions, test higher memory because memory also increases available CPU. Question number 24. A Lambda function calls an external payment API continuously. Some failures are expected, but support must be notified through an existing SNS topic only when failures exceed 5% of transactions during a 1-hour period. Which solution meets the requirement? Option A. Emit custom CloudWatch metrics for total calls and failures. Create the required error rate alarm and target the existing SNS topic. Option B. Store results in S3 and schedule Athena queries that attempt to notify SNS. Option C. Publish every failed request to a new SNS topic. Option D. Query CloudWatch logs insights from a scheduled Lambda function and manually calculate the rate. The correct answer is A. Emit custom CloudWatch metrics for total calls and failures, create the required error rate alarm, and target the existing SNS topic. Here's why. CloudWatch metrics and alarms provide near real-time threshold evaluation, and the alarm can notify the existing SNS topic when the hourly rate exceeds 5%. Why are the other options not correct? B and D add scheduled query workflows and delay. C notifies on individual failures, uses a new topic, and does not evaluate the required percentage. Exam tip. Use metrics and alarms for numerical thresholds. Use logs when detailed event investigation is required. Question number 25. A public, unauthenticated API built with API Gateway and Lambda returns statistical data that changes once per day. Request volume has increased, and the company wants lower response latency and fewer backend invocations. Which action should the developer take? Option A. Require API keys and usage plans. Option B. Enable API Gateway caching. Option C. Enable CORS. Option D. Use an interface VPC endpoint for API Gateway. The correct answer is B. Enable API Gateway caching. Here's why. API caching serves repeated responses without invoking Lambda for every request, improving latency for data that changes only daily. Why are the other options not correct? A controls usage. C enables browser cross-origin access, and D provides private connectivity. None directly caches responses. Exam tip. Enable API Gateway caching for repeatedly requested, cacheable responses with acceptable staleness. Question number 26. A catalog stores book records with an ISBN edition, publication year, category, and optional attributes that vary between books. The application must retrieve one edition by title and year, all editions for a title, and all books in a category. Which DynamoDB design supports these access patterns? Option A. Use category as the table partition key and publication year as the sort key. Create a GSI on title only. Option B. Use title as the partition key and publication year as the sort key. Create a GSI with category as the partition key and title as the sort key. Option C. Use an RDS table with title as the only primary key and fixed columns for title, year, and category. Option D. Use an RDS table with title as the only primary key and place all other attributes in one JSON column. The correct answer is B. Use title as the partition key and publication year as the sort key. Create a GSI with category as the partition key and title as the sort key. Here's why. The base key supports one edition and all editions of a title. The GSI supports querying every item in a category while allowing flexible attributes per item. Why are the other options not correct? A cannot uniquely and efficiently support all required title and year access patterns. C and D use title alone as a primary key, so multiple editions conflict. Exam tip. Design DynamoDB keys from access patterns. Add a GSI when a query needs a different partition key. Question number 27. A reporting application is moving a read-heavy MySQL workload to Amazon RDS. The development team wants to scale query throughput with the least ongoing administration. Which solution should be used? Option A. Create one or more RDS read replicas and direct read queries to the replica endpoints. Option B. Use multi-availability zone and connect read queries to the standby instance. Option C. Increase the application's connection pool against the primary in a multi-availability zone deployment. Option D. Build and maintain MySQL replication on an EC2 instance. The correct answer is A. Create one or more RDS read replicas and direct read queries to the replica endpoints. Here's why. Read replicas are designed to scale read traffic and are managed by RDS, minimizing current and future operational effort. Why are the other options not correct? B. Multi-availability zone standbys are not general read endpoints. C. Adds primary load. D. Requires self-managed replication on EC2. Exam tip. Use RDS read replicas for read scaling. Multi-availability zone primarily provides high availability and failover. Question number 28. An application uploads objects by calling the Amazon S3 PutObject API. Every new object must use server-side encryption with Amazon S3 Managed Keys, SSES3. Which request configuration meets the requirement? Option A. Send the XAM's server-side encryption header with the value AES256. Option B. Supply a customer-provided encryption key in every request header. Option C. Create a customer-managed KMS key and assign it to the bucket. Option D. Use TLS for the request without specifying at-rest encryption. The correct answer is A. Send the XAM's server-side encryption header with the value AES256. Here's why. For PutObject, the AES256 value requests SSES3, causing S3 to encrypt the object at rest with S3 managed keys. Why are the other options not correct? B is SSEC, C describes SSEKMS, and D protects data in transit but does not select the required at-rest encryption mode. Exam tip. SSES3 uses the PutObject header XAM's server-side encryption, AES256. Question number 29. A performance testing team must deploy the same load generation resources into several AWS regions. The resources are already defined in CloudFormation, and the deployment must not require new application code. Which approach should the team use? Option A. Run the AWS CLI deploy commands separately for each region. Option B. Define the resources in a Systems Manager document and execute it in every region. Option C. Use CloudFormation stack sets through the AWS CLI to deploy stacks to the required regions. Option D. Deploy a Lambda function in each region that creates a CloudFormation stack. The correct answer is C. Use CloudFormation stack sets through the AWS CLI to deploy stacks to the required regions. Here's why. Stack sets deploy a common CloudFormation template across multiple accounts or regions without custom application code. Why are the other options not correct? A requires repeated regional deployments. B. Systems Manager documents are not the native multi-region stack mechanism. D. Adds unnecessary Lambda code and management. Exam tip. Use CloudFormation stack sets for centrally managed, repeatable multi-region or multi-account stack deployment. Question number 30. A developer is defining a serverless application in YAML. The application contains API gateway, APIs, Lambda, functions, and DynamoDB tables. Which AWS framework provides simplified serverless resource definitions that are transformed into CloudFormation? Option A. AWS Cloud Development Kit, AWS CDK. Option B. AWS Serverless Application Model, AWS SAM. Option C. AWS Elastic Beanstalk. Option D. CloudFormation Serverless Intrinsic Functions. The correct answer is B. AWS Serverless Application Model, AWS SAM. Here's why. AWS SAM adds concise YAML resource types for serverless applications and transforms them into CloudFormation resources. Why are the other options not correct? A CDK uses programming languages rather than being the requested YAML serverless extension. C is a platform service. D is not a defined CloudFormation feature. Exam tip. Use AWS SAM for concise YAML definitions of Lambda, API gateway, and related serverless resources. Question number 31. A document processing service must create an item in an Amazon DynamoDB table immediately after an object is uploaded to a specific Amazon S3 bucket. The solution should be event-driven and must not repeatedly scan the bucket. Which implementation meets these requirements? Option A. Run an AWS Lambda function on a schedule to list the bucket and write newly discovered objects to DynamoDB. Option B. Create a recurring operating system cron task that checks Amazon S3 and writes records to DynamoDB. Option C. Configure an S3 event notification to invoke an AWS Lambda function that writes the object metadata to DynamoDB. Option D. Create an Amazon Event Bridge scheduled rule that periodically checks the bucket and directly inserts items into DynamoDB. The correct answer is C. configure an S3 event notification to invoke an AWS Lambda function that writes the object metadata to DynamoDB. Here's why. Amazon S3 can invoke Lambda when an object is created, and the function can use the DynamoDB API to write the corresponding item immediately. Why are the other options not correct? A. Scheduled polling is not immediate and repeatedly lists the bucket. B. A cron task adds server management and is not event-driven. D. A scheduled event bridge rule is periodic and does not itself implement the required object processing logic. Exam tip. For immediate processing of new S3 objects, use an S3 event notification with a supported destination, such as Lambda. Question number 32. A team deploys an application and its Amazon RDS database from one AWS CloudFormation template. During a stack update, a database replacement deleted development data. The team must protect the database from both accidental updates and deletion while continuing to manage the application through CloudFormation. Which two changes meet these requirements? Choose 2. Option A. Convert the RDS database to a multi-availability zone deployment. Option B. Apply a deletion policy with the retain value to the RDS resource. Option C. Deploy the template by using AWS CloudFormation stack sets. Option D. Add a stack policy that denies update actions against the RDS resource. E. Add a deletion policy with the retain value to the CloudFormation stack itself. The correct answer is B. Apply a deletion policy with the retain value to the RDS resource. D. Add a stack policy that denies update actions against the RDS resource. Here's why. Retain prevents CloudFormation from deleting the database when the resource is removed or the stack is deleted. A stack policy can block updates that would modify or replace the protected database. Why are the other options not correct? A. Multi-availability zone improves availability, but does not prevent CloudFormation deletion or replacement. C. Stack sets deploy stacks across accounts or regions. They do not protect a resource. E. Deletion policy is a resource attribute, not a stack-level attribute. Exam tip. Use deletion policy for delete behavior and a stack policy to restrict update actions against critical resources. Question number 33. An application running on an Amazon EC2 instance displays the object names from an Amazon S3 bucket. The application receives no results because its AWS permissions do not allow the bucket to be listed. What is the most secure correction? Option A. Grant the developer's IAM user the S3 list bucket permission for the bucket. Option B. Grant the EC2 instance role S3 * permissions for the bucket and all of its objects. Option C. Add a bucket policy that grants S3 list bucket to the AWS account number associated with the EC2 instance. Option D. Grant the EC2 instance role only the S3 list bucket permission on the bucket ARN. The correct answer is D. Grant the EC2 instance role only the S3 list bucket permission on the bucket ARN. Here's why. The application needs to list the bucket, so the attached instance role requires S3 list bucket on the bucket resource. This follows least privilege. Why are the other options not correct? A. The application uses the EC2 role, not the developer's IAM user. B. S3 * grants far more permissions than are required. C. An account number is not an EC2 instance principal, and the permission should be granted to the instance role. Exam tip. Grant EC2 applications permissions through the instance role and scope S3 list permissions to the bucket ARN. Question number 34. A serverless reporting function must query an Amazon Aurora MySQL cluster. The database is reachable only from private subnets in the application's VPC. The function must connect without exposing the database to the public internet. Which configuration meets the requirement? Option A. Export the relational data to Amazon S3 and have a Lambda function query the exported objects instead of Aurora. Option B. Attach the Lambda function to private subnets in the database VPC. Associate the same security group with the function and Aurora and permit self-referenced TCP traffic on port 3306. Option C. Place the Lambda function in a public subnet of another VPC and connect the VPCs by using VPC peering. Option D. Attach one security group to the Lambda function and another to Aurora, but add the MySQL inbound rule to the Lambda function's security group. The correct answer is B. Attach the Lambda function to private subnets in the database VPC. Associate the same security group with the function and Aurora, and permit self-referenced TCP traffic on port 3306. Here's why. VPC attachment gives the function private network interfaces in the VPC, and the security group rule permits MySQL traffic between the function and Aurora without public exposure. Why are the other options not correct? A. Exporting data changes the access pattern and does not provide direct relational queries. C. A public subnet in another VPC adds unnecessary networking and does not make Lambda publicly routable by itself. D. The inbound rule belongs on the database side, not only on the Lambda security group. Exam tip. A Lambda function must be VPC-enabled and allowed by the database security group to reach a private RDS or Aurora endpoint. Question number 35. A mobile development team is testing an Amazon API Gateway REST API before the backend is available. Depending on a request parameter, the API must return one of several predefined responses without invoking any compute service. Which solution has the least operational overhead? Option A. Provision an Amazon EC2 instance that returns the required test responses. Option B. Use API Gateway stage variables to choose a response without configuring an integration. Option C. Invoke an AWS Lambda proxy integration that returns hard-coded responses. Option D. Configure an API Gateway mock integration and use an integration request mapping template to select the response. The correct answer is D. Configure an API Gateway mock integration and use an integration request mapping template to select the response. Here's why. A mock integration lets API Gateway generate a response without calling a backend, and the mapping template can choose among predefined responses. Why are the other options not correct? A. EC2 adds unnecessary infrastructure and administration. B. Stage variables hold environment-specific values but do not generate mock responses by themselves. C. Lambda can return constants, but it adds code and invocation overhead. Exam tip. Use an API Gateway mock integration when testing requires responses without a backend service. Question number 36. A healthcare application stores encrypted records in Amazon RDS from MySQL, frequently read. Values must also be cached with encryption in transit and at rest. The cache must support ordered rankings for features such as priority lists and leaderboards. Which solution satisfies these requirements? Option A. Add an encrypted RDS read replica and use it as an application cache. Option B. Copy the values to Amazon DynamoDB and place a DynamoDB accelerator cluster in front of the table. Option C. Use Amazon Elastic Cache for RedISS OSS with in-transit and at-rest encryption and store ranked values in sorted sets. Option D. Use Amazon Elastic Cache for Memcached with encryption and store ranked values in the cache. The correct answer is C. Use Amazon Elastic Cache for RedISS OSS with in-transit and at-rest encryption and store ranked values in sorted sets. Here's why. RedISS OSS supports sorted sets for ranking and ordering, while Elastic Cache supports encryption in transit and at rest for protected cache data. Why are the other options not correct? A. A read replica serves database reads but is not an in-memory cache with sorted set operations. B. DAX is a DynamoDB cache and does not directly cache the existing RDS workload. D. Memcached does not provide RedISS sorted set data structures for rankings. Exam tip. Choose Elastic Cache for RedISS OSS or Valkey when the cache needs advanced data structures such as sorted sets. Question number 37. A digital agency manages several static sites whose repositories are hosted and supported. Git providers. Each repository has development, test, acceptance, and production branches. A merge into a branch must automatically deploy the corresponding environment. All sites must use HTTPS, and the company does not want continuously running servers. Which approach provides the least operational overhead? Option A. Store each environment in a separate S3 bucket and build a custom code pipeline and code build deployment workflow. Option B. Use AWS Amplify hosting Connect each environment branch and enable branch-based continuous deployment. Option C. Create multiple AWS Elastic Beanstalk environments and associate each branch with an EBS-CLI deployment process. Option D. Run every site on a separate Amazon EC2 instance and trigger a custom copy script after each merge. The correct answer is B. Use AWS Amplify hosting. Connect each environment branch and enable branch-based continuous deployment. Here's why. Amplify hosting supports Git-based branch deployments, managed HTTPS, and serverless static site hosting without continuously running servers. Why are the other options not correct? A. S3 with custom pipeline stages can work, but requires more components and management. C. Elastic Beanstalk runs application environments and adds unnecessary compute for static sites. D. EC2 requires server administration and custom deployment automation. Exam tip. Amplify hosting maps Git branches to managed front-end environments and can deploy automatically after commits or merges. Question number 38. A fleet of connected sensors sends requests to a Lambda-backed REST API. Every request contains a unique operation ID. Traffic is highly variable, and clients retry requests. After throttling, processing the same operation more than once could create inconsistent data, which design provides scalable idempotent processing. Option A. Store operation IDs in Amazon Elastic Cache for Memcached and check the cache before processing each request. Option B. Use an Amazon DynamoDB table as an idempotency store and perform a conditional write for the operation ID before processing the request. Option C. Store operation IDs in an Amazon RDS for MySQL table and query the table before each request is processed. Option D. Save operation IDs in DynamoDB, but return a client error whenever a retry contains an existing ID. The correct answer is B. Use an Amazon DynamoDB table as an idempotency store and perform a conditional write for the operation ID before processing the request. Here's why. DynamoDB scales for bursty request volumes, and a conditional write can atomically claim an operation ID, so retries do not repeat the business action. Why are the other options not correct? A. Memcached entries are not durable and can be evicted, allowing duplicate processing. C. RDS can store identifiers but adds connection and scaling overhead for a highly variable serverless workload. D. Returning an error does not provide retry-safe idempotent behavior or a reusable result. Exam tip. Implement idempotency with a durable key store and an atomic conditional write, not a separate read-then-write sequence. Question number 39. A REST API is deployed through Amazon API Gateway in the US West 2 region. The developer is configuring an edge-optimized custom domain, which uses an API Gateway managed CloudFront distribution. A certificate issued by an external certificate authority is available. How should the custom domain be configured? Option A. Import the certificate into AWS Certificate Manager in US West 2 and create a DNS name record. Option B. Upload the certificate directly to the CloudFront distribution and create a DNS name record. Option C. Import the certificate into AWS Certificate Manager in US East 1 and create a DNS name record that points to the generated domain target. Option D. Import the certificate into AWS Certificate Manager in US West 2 and create only a DNS record. The correct answer is C. Import the certificate into AWS Certificate Manager in US East 1 and create a DNS name record that points to the generated domain target. Here's why. An edge-optimized API Gateway custom domain uses CloudFront and requires its ACM certificate in US East 1. DNS must route the custom host name to the generated target. Why are the other options not correct? A. A certificate in the API's region is used for a regional custom domain, not an edge-optimized domain. B. The API Gateway Managed CloudFront distribution is not configured by uploading the certificate directly to CloudFront. D. The certificate region is incorrect, and an A record alone is not the stated mapping. Exam tip. API Gateway Edge Optimized Custom Domains Use ACM Certificates in US, East. 1. Regional Custom Domains Use Certificates in the API region. Question number 40. An AWS Lambda function reads from a DynamoDB table. The table name differs between environments and can change after deployment. The developer wants to update the table name without rebuilding or changing the function code. Which solution is most efficient? Option A. Put the table name in a file that is packaged in a Lambda layer. Option B. Declare the table name as a global constant outside the function handler. Option C. Write the table name to a file in the functions/tmp directory. Option D. Store the table name in a Lambda environment variable and read it through the programming language's environment interface. The correct answer is D. Store the table name in a Lambda environment variable and read it through the programming language's environment interface. Here's why. Environment variables separate deployment configuration from function code and can be updated without rebuilding the deployment package. Why are the other options not correct? A. A layer is version deployment content and must be republished when the value changes. B. A hard-coded global constant still requires a code update. C/TMP is ephemeral runtime storage and is not a deployment configuration source. Exam tip. Put non-secret environment-specific Lambda settings in environment variables. Use a secret service for credentials. Question number 41. A team is decomposing a monolithic application into AWS Lambda functions. The existing Amazon Aurora cluster runs in private subnets. The functions and database are in the same AWS account, region, and VPC. Connections must remain on private network paths. Which action is required? Option A. Add a NAT gateway and assign a security group to the Lambda functions. Option B. Configure the Lambda functions with the VPC, private subnets, and security groups that permit access to the Aurora cluster. Option C. Enable public accessibility on the Aurora cluster. Option D. Create an Amazon RDS proxy without configuring VPC connectivity for the Lambda functions. The correct answer is B. Configure the Lambda functions with the VPC, private subnets, and security groups that permit access to the Aurora cluster. Here's why. VPC configuration creates network interfaces for Lambda in the selected subnets, allowing private connectivity to Aurora when security groups permit the database port. Why are the other options not correct? A. A NAT gateway provides outbound internet access and is not required for private Aurora connectivity. C. Public database access violates the private connectivity requirement. D. RDS proxy can improve connection management, but the function still needs network connectivity to the proxy in the VPC. Exam tip. VPC-hosted databases require Lambda VPC configuration plus security group rules. A NAT gateway is for outbound internet access. Question number 42. A Node.js Lambda function must include a correlation value in every log message so that events from one invocation can be distinguished from events produced by concurrent invocations. Which implementation meets this requirement? Option A. Read the AWS request ID from the event object and write messages to standard output. Option B. Read context.aws request ID and write the log messages to standard output. Option C. Read the AWS request ID from the event object and append messages to a local file. Option D. Read context.aws request ID and append the messages to a local file. The correct answer is B. Read context.aws request ID and write the log messages to standard output. Here's why. Lambda supplies a unique invocation request ID in the context object, and messages written to standard output are sent to the function's CloudWatch log stream. Why are the other options not correct? A. The event payload does not universally contain the Lambda invocation request ID. C. It uses the wrong source for the ID, and local files are not the standard logging path. D. The ID source is correct, but writing to a local file does not automatically publish the messages to CloudWatch logs. Exam tip. Use the Lambda context request ID as a per-invocation correlation value and log through standard output. Question number 43. An EC2 auto-scaling group launches instances slowly because its user data installs operating system updates, management agents, and the application. The team must shorten Launch time. Validate each AMI. Keep security patches current. Deploy the newest. Application release. And avoid building a new AMI for every application change. Which 2 actions should the developer take? Choose 2. Option A. Use AWS Code Pipeline as the service that installs the newest application release on each instance at launch. Option B. Use EC2 Image Builder to create and validate an AMI containing the required operating system patches and management agents, and reference it in the launch template. Option C. Use EC2 Image Builder to bake the newest application release, patches, and agents into a new AMI for every release. Option D. Use AWS Code Deploy to install the current application revision on instances launched from the validated AMI. E. Remove patching commands from user data without adding patch installation to the image. Build. The correct answer is B. Use EC2 Image Builder to create and validate an AMI containing the required operating system patches and management agents, and reference it in the launch template. D. Use AWS Code Deploy to install the current application revision on instances launched from the validated AMI. Here's why. Baking stable operating system dependencies into a validated AMI shortens bootstrapping. Deploying the applications separately with Code Deploy keeps releases current without creating an AMI for every code change. Why are the other options not correct? A. Code Pipeline orchestrates workflow stages, but is not the instance deployment agent. C. Baking every application release creates more AMIs than required. E. Removing patching without moving it into the image leaves instances unpatched. Exam tip. Bake slow, stable dependencies into validated images and deploy frequently changing application code through Code Deploy. You have completed part 1 of the DVA-C02 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.